I just did. I accidentally instructed the computer to fill the screen with green. Well, I guess I'll just have to straighten out that instruction.
I can't find this book. You know, we're gonna have to straighten this place up.
What's the matter, Mark? Can't find your way to the refrigerator?
Ha, ha. Well, it just so happens I can't find my library book, and I gotta write a report for tomorrow.
Poor Mark. Can't find your book?
Hey, listen, I didn't make all this mess by myself. You know, you guys never give me a hand or anything around here. We gotta get some order in this place.
Well, I can. I've got more important problems right here.
Well, excuse me. And I guess you've got more important things to do, too, huh?
Well, as a matter of fact, I do.
Oh, so cleaning's not important anymore.
Now, wait a second. I didn't say that, Mark.
Oh, come on, Mark. Cut it out.
Well, I'm not gonna clean this place up all by myself.
No, nobody asked you to.
You know, I didn't make all this mess.
You're the one who didn't make it.
Look over here. You guys got the kitchen.
Wait, hold it. Stop it. Come on, you guys. Now, look what we're doing. We're out of order now. We're getting as disorderly as this place.
Well, what are we gonna do about it?
3, 2, 1. Contact is the secret, is the moment when everything happens. Contact is the answer, is the reason why everything happens. Contact. Let's make contact. 3, 2, 1.
Fellas, this is a simple overhand layup off the wrong leg, I think. Simple. Okay. You've all been waiting on this one, only because you're experts on the subject.
What?
Disorder. Today we're talking about disorder.
Are you calling us disorderly? I'm insulted. Me too. What?
At moments like this, I try to be calm. I remind myself that everything in the universe tends towards disorder. But I don't like that tendency.
Hey, get it together!
Okay, now the first thing we have to do to restore order among us is to apologize. Mark, I'm sorry, okay? Now, I know I made some of this mess, too.
Yeah, I'm sorry too, Mark, but it really upsets me when you yell like that.
Well, I'm sorry I got so angry, but I can't find anything around this place. And I really need to find that library book.
Hey, is this what people mean when they say everything in the universe tends towards disorder?
Well, disorder is a lot more than just a sloppy place. But look, let me show you some. Do you know where those cards are that I had?
They're around here someplace.
Oh, here they are. Look. Now watch. See? They're all in order, right?
Right.
2, 3, 4, 5, 6, 7, 8.
Mm-hmm.
Okay, now, what do you think would happen if I shuffled them? What do you think the chances are that they'd come back accidentally in order?
Not a chance.
No way, it's impossible.
Well, let's see.
Yeah.
See? Look. They're all out of order.
Yep.
Like we said. Okay, wait, I have another example. Let me show you something else. Let's clean this up a little bit.
Oh, okay.
Here's the ant farm over here. Okay, now, what do you think would happen if I put this jar of ink into the water?
The ink's gonna get out.
Let's see. Exactly. And it would never happen the other way around. The ink would never go back into the jar by itself.
So that's what people mean when they say the universe tends towards disorder.
Right. This is disorder, too. Volcanoes and other natural catastrophes are really examples of disorder on a grand scale.
Man.
Enormous amounts of energy are released.
Yeah. Sometimes whole villages get destroyed.
I guess tornadoes are another spectacular example of disorder. I sure wouldn't want to be in its path.
Then you've got hurricanes and floods.
Don't forget erosion. Soil's constantly being washed away, wearing down the land.
But the soil ends up somewhere else.
Okay, so things break down. But can't you use the products of decay to make new products?
Sure. Take a forest. When animals and plants die, they get recycled. A whole army of decomposers, like mushrooms and other tiny organisms that live in the soil, go to work. Decomposers break down dead matter. Of course, they die too. Leaf-cutting ants carry waste from their underground nest and deposit it on the soil where it can be reused.
Dung beetles even feed waste to their young.
Fruit doesn't lie on the ground very long before decomposition begins. This puts nutrients like phosphorus and nitrogen back into the soil. The same thing happens to dead animals.
So, dead things end up becoming new food for plants.
Then the plants grow and die, and the cycle starts all over again.
Right, and we can do the same thing with our waste material.
You know, there was a time when I thought humans were as smart as we are.
Guess where I am? 35 feet underground at a sewage treatment plant. Yuck! See all this dirt and filth? It all comes from our homes and from factories and streets. It all goes down the sewer and it ends up in a place like this where it gets cleaned up and made reusable. I'm with Dr. Robinson, and we're at the West-Southwest Sewage Treatment Plant in Chicago, Illinois. She's an environmental engineer. Dr. Robinson, I mean, this just looks like, look to me, what could you possibly expect to get from it that you can use again?
Okay, Lisa, what we're going to do with this water is we're going to clean it up and put it back out into the river to be reused again. This is the first step in the wastewater treatment process. And this room that we're in is called the screening room. And the function is to remove the large material that comes in with the wastewater in the sewer. Sometimes we get bicycles, mattresses, chairs.
In a sewer?
In a sewer coming in. Anything people can get down the sewer, they will, and it ends up here, and we get it out.
Well, how much water do you think gets this treatment every day?
If you took 14,000 Olympic-sized swimming pools and filled them up, that would be about the same amount of water that goes through this plant every day.
It's a lot of dirty water.
But at the end of the process, it's a lot of clean water that goes back to our rivers. These are the aeration units. For this wastewater treatment plant, this is the key to wastewater treatment. Basically, what we do is bubble oxygen up through the wastewater to give the microorganisms that are purifying the water enough oxygen so that they can adequately feed on the solution.
This is the same filthy water that was coming through the screening room.
This is the same filthy water, but now it's really not, it's not filthy anymore. It's being cleaned up here in this unit right here.
Right.
Now, we just took a sample, and I'm going to take this back to the lab and show you what the bacteria look like under the microscope.
These guys are actually alive and they're eating the bacteria?
Yes, the bacteria have purified the solution, and now they are being fed upon by this rotifer here.
Why is it good that this organism is eating the bacteria?
Because we're taking advantage of the bacteria that are in the sewage, and we're using them to clean up the wastewater. In fact, these are the workers. They're doing all of the work.
Well, I thought all bacteria was bad for you.
No, we have good bacteria and bad bacteria.
Oh, like when you eat a piece of fruit that's rotten, you get a stomachache.
That's bad bacteria. Good bacteria that we take advantage of feed on the organic matter that's in the wastewater. Then they clump together and form these masses that you see here, and these are millions of bacterial cells. And then this guy comes along and feeds on the bacteria, and he gets them out of solution, and we have a purified wastewater.
But you still have this guy, don't you?
See, the worm is also feeding on bacteria. All of this stuff you see here, the solids or the sludge, and it settles down to the bottom of the basin, and the purified wastewater is on the top. We draw the sludge off of the bottom of the basin, and we take the purified wastewater off at the top and send it to the stream.
So the sludge that is settling on the bottom of this tank, is that the same thing that was on that microscope that we saw?
It's the very same thing. It is now purified water, clean water. Goes to our river. The solid settles to the bottom, which makes the sludge, and then we take the sludge over to another room and make fertilizer out of it. This is it, Lisa. These are the living microorganisms that we saw in the bottom of the aeration basin, and then we took it over to the settling basin, and I told you that we were pulling some material off of the bottom of the basin. This is it right here. This is called sludge. This equipment that you see here is called a vacuum filter, and the function of this filter is to pull water out of the sludge so it can dry faster.
What would happen if we didn't do that? Take the dirt from the sewer and clean it up.
If we did not do this and depended on nature to do it, you would find that it would take nature hundreds of years to do this. And in the process, we would really destroy nature.
What happens to all this sludge after it oozes off the barrel and goes onto the belt?
All right, Lee, so this material is taken over to another room where it's made into fertilizer.
What makes it good fertilizer?
It has everything in it that plants need to grow. It has nitrogen, phosphorus, organic matter, and other essential elements.
Can I touch that?
Oh, no, Lisa, don't touch that.
Why not?
This material not only has the good bacteria that was in it to help purify the wastewater, but it also has the harmful bacteria that were also in the wastewater. Everything that was in the wastewater is now in this material, and it's not ready to be touched yet.
Only after it becomes fertilizer?
Only after it becomes fertilizer, or only after we stabilize it can you touch it.
So is this the end of the treatment process?
Yes, and this is the end of our story. We've taken that sludge that you saw, and we made fertilizer out of it. We cleaned up that dirty water, and we put it back into the river.
So now that we've put it back into the river, we're going to be able to use it in our homes, right?
It will eventually end up back into our homes, our stores, and our factories.
But if it does go in our homes and we use it, it's just going to go right down the drain again.
And it's going to come right back here, and the cycle is going to start all over again.
Okay, I can take care of my computer problem later. I'll help clean up.
Okay.
You know, if we all pitch in, it won't take so long.
Right.
Would you look at what we're throwing away? You know, a lot of this stuff can be recycled if we were willing to spend the time and effort. You know, these can be made into new paper.
Yep, and these can be recycled into new glass.
And don't forget about these.
Hey! You're illiterate, and you're also wasting aluminum and energy.
What is one can?
There's a lot of work in just making one can.
Aluminum is made from an ore called bauxite. Ore is rock with metal mixed in. It's a lot of work to mine it. First you have to dig it up, then you have to transport it from different parts of the world, and above all, it takes a lot of energy to refine it. Refining is the process of separating the aluminum from the rock. It takes 20 times as much energy to make a can from ore than from recycled aluminum. Plus, there's only just so much aluminum ore in the ground.
Hi. Aluminum goes on this side, tin and bimetal goes on that side over there. Okay?
This is a recycling plant. Cans are weighed. People get paid to bring them back for recycling. The aluminum cans, when they reach the top, are dumped into a bin. The steel cans stick to the conveyor belt because it's magnetized. Steel sticks to a magnet, and the cans drop into a different barrel. The aluminum cans go up another conveyor belt and into a shredding machine. We can't see it, but they're being torn into little tiny bits about the size of popcorn. The shreds then go into the blower, which blows them up the pipe, and right into the body of a truck, which is backed up to a doorway in the wall of the plant. Shreds are good because they take up less room in the truck, and they melt down faster than whole cans. The truck takes the shreds back to the refining plant, where they're melted down and cast into ingots again. The ingots are rolled into sheets, and the sheets are made into great big rolls and are delivered to a plant where soda cans are made. We have to wear eyeglasses to protect our eyes and earplugs to protect our ears.
Why do we have to wear ear?
Little cups are being punched out of the sheet like a cookie cutter. The little cups are fed down into a machine which pulls up the sides until they become full length. The top edge is trimmed off and the cans are washed. Then they travel to where they're decorated. The cans are printed, not painted. All the colors go on at one time. Then the cans are baked dry and inspected. Those stacks of cans are now ready to be shipped to the plants where the soda is put in and the tops are put on. And they're delivered to stores, and the whole process starts all over again.
Hey, that's littering and a waste of aluminum and good energy. Well, what's one can? One can. It takes a lot of energy to make one can.
So you see, you can turn disorder into order.
Yeah, but it takes work. And in the long run, we're always fighting the tendency toward disorder.
Well, life is order, although sometimes you wonder. You know, I still haven't found my library book.
Well, why don't you try your locker, Mark? Maybe it needs to be put in order.
Now I want to put that computer program into order so I can finish that quilt design I've been working on. Can you help me?
Oh, sure. What's the problem?
Look at it.
Oh, Lisa, that's a sheet, not a quilt.
I know. Look at
All
it.
right, well, let's tell the computer to get the green off the screen.
Okay.
See? It does exactly what you tell it. Now, what do you want the computer to do?
Well, there are three things that I want to control.
Okay.
Now, I want to choose the color for the squares. I also want to decide how large they're going to be and where they're going to be put.
Okay, well, let's start with size, okay? Now, see, I think,
Yeah, I was working on something, but
yeah. There you go, how's that?
that's pretty good. But I think I'd like them a little bit bigger. They're too small.
But that pattern's okay, though?
Yeah.
Okay.
Let's see.
How's that?
Now, that's a good size, but can we make those outside ones red?
Okay.
Yeah, so I want the red on the outside.
How's that? There you go.
That's it, yeah.
That looks nice.
It's good. Okay, now I was thinking of some blue ones in the
Why
middle
don't you
there.
try?
Okay.
See what you
Let me
can
show
come
you
up
what
with.
I've been doing. Okay. See?
One. Yeah.
Like that.
That's good. That's pretty.
Yeah. Okay, now red and blue. Let's have yellow, I think.
Yeah, how, around here?
Yeah.
That's good.
Here we go.
That's it. You got it. Now you're in control.
You really helped me solve my problem. You know, I can't believe I actually used a computer to design my quilt pattern.
Yeah. You know, the Bloodhound Gang ought to get a computer to help solve their cases.
Whenever there's trouble, we're there on the double. We're the Bloodhound Gang. If you've got the crime, we've got the time. We're the Bloodhound Gang.
Vicky saw a purse snatched and chased the thief. As she was about to return the purse, Vicky saw two men kidnap Mrs. Frimple. In the purse, there was only a blank piece of paper. By scribbling with a soft charcoal pencil, a secret message written in salt water was revealed.
Sounds like Tennessee to me.
Mr. Aces, alias Mr. Big, called and said he'd be right over for the purse. The Bloodhound Gang substituted a blank sheet of paper and hid the real message. But it was Mrs. Frimple who came for the purse. She denied she had been kidnapped.
Her story's fishy.
Now for the conclusion of the case of the secret message.
Let's have it.
Have what? Do you have an appointment?
Knuckles, give them my card.
Which one, boss?
Pick any one.
Aces model airplanes specializing in radio control. So you must be Mr. Aces.
Hand over the purse.
How's your aunt?
All shook up? Can't leave a room? Come on, kids. I'm in a hurry.
I'm sorry, Mr. Aces, but we don't have the purse.
Oh, give me that. Anything happens on the streets, and I know about it. You got the purse.
Had it. Your aunt picked it up a few minutes ago.
You told me the old lady was...
These punks are lying, boss.
You tear this room apart to find it. Well, well.
You want me to put these kids on ice, boss?
No. Bunch of numbers. What do they know? Come on.
Let's see if there's a Tennessee Bay around here. Anyone remember all those numbers?
Started with a 9.
25. 9/25. 9/25. Hey, that's today's date. September 25th.
Here it is, Tennessee Bay, just outside the city. What was the rest of the message?
1730. Hey, if the first set is the date, the second set could be the time.
That's the way they tell time on ships.
Great, but what time does that make it?
You don't start over at noon. Like 1 o'clock is 1,300 hours, and 2 o'clock is 1,400, and so on.
Then 1730, subtract 12, you get...
5:30. And that's 5:30 today. I wonder what's going to happen.
Ships.
Smuggling?
Of course, at Tennessee Bay.
Thanks, Mr. Bloodhound.
I can't see anything. Wait. There's a ship over there.
Looks cozy. Is there room in there for one more?
Mrs. Frimple.
Police Detective Monroe.
Did you shadow us here?
If you were clever enough to switch the message, I figured you were clever enough to lead me to the pickup spot. Mr. Big has eyes in the back of his head.
Every time we put a tail on him, it leads us on a wild goose chase. My partner staked himself out further up the road.
Hey, listen.
What is it? Sounds like a model airplane to me.
It is. We figured he was using that shop of his as a front. Now all I gotta do is find the radio frequency he's using to guide the plane. Got it. There.
It's turning this way, I see it.
Now it's following our signal.
It's heading right for us. Think it's Ace's?
What's could it be? Look for evidence. They must be smuggling something inside.
From the ship out there?
Right. Look, what's this? Diamonds.
Don't move. Hijacking model airplanes. Tisk, tisk, tisk.
Smuggling diamonds. Tisk, indeed. You're under arrest.
Oh, says who?
Says me. Knuckles, drop the gun. Now put your mitts behind you. You too. And turn around.
What's this? Your gang. Good job. Oh, no, not another secret message.
That's no secret. Well, what does it mean? Whenever there's trouble,
We're there on the double.
Mr. Bloodhound isn't here.
It's a game show. It's a geography lesson. It's a mystery. It's the search for Carmen Sandiego, and it continues today at 4:30. Now, stick around for Square One TV.
Today we've been talking about disorder. Without some effort to keep order, everything in the universe tends to break down, to decay into disorder.
Now, how's that for making order out of disorder? It's beautiful. Yeah, thanks a lot for helping me, Trine. Hey, maybe I'll join that computer workshop you go to. Yeah, that's a good idea. Hey, now you can start putting these in order. Well, that's my first order of business.
Hey, I found my book.
You mean we did all this cleaning up and it was in your locker all the time?
Well, you said we need some order to survive.
Hey, Mark, I could use some help making my quilt. Yeah, Mark, and you can use some practice in keeping things in order.
Okay.
Okay, get the red one here.
321 Contact is a production of the Children's Television Workshop.